couple examples on rationalizing a denominator of a fraction, algebraic fraction. In other words, to rewrite the fraction so that there is not a square root in the denominator. In the first case here, I have 3 divided by the square root of 2. The very simple thing to do, remember, is if I could multiply the denominator square root of 2 by itself, the square root of 2, I would get 2, and that would do it. But whatever I do to the denominator, I would have to also do to the numerator. In other words, if I'm going to multiply that fraction by something, it should be some form of 1, so it doesn't change the actual value of the problem. So I would have 3 square root of 2 over 2. And this is a rationalized version of the first fraction. Now another example is to deal with a situation where you could have 2 terms in the denominator, and one of them being a square root or a radical of some kind. The trick there is to make use of our difference of squares formula, and I'm going to take, in this case, that square root of x minus 2 and multiply it by the square root of x plus 2. So then my answer will be a difference of squares, squaring the square root of x and then squaring the 2. And that would, again, eliminate the radical. But again, whatever I do to the denominator, I'm going to also have to do to the numerator. So I'll have 4 times the square root of x plus 2 in the numerator. In the denominator, I'll have the difference of squares. So I'll have the square root of x squared, and I'll have the 2 squared. So 4 square roots of x plus 8 divided by x minus